The road construction process typically starts when a road construction company wins a contract to build the road. The contract document contains all of the information they need to construct the road, including drawings showing how it is laid out, and specifications providing detailed information about the materials and standards of workmanship required to ensure the road will be able to function. This video provides a quick overview of the complete road construction process. We will look at the details of each process in the relevant micro-credentials. The first construction activity is to remove the vegetation and topsoil off-site. Any trees, shrubs and debris is removed and taken to disposal. If the site is grass, then it is best to cut it or have it grazed to a low level to lessen the amount of grass mixed in with the topsoil. Topsoil is the organic material on the surface of most sites. It is not suitable as a foundation for roads as it is generally soft and swells when wet. Therefore, it needs to be removed across the whole width of the road. It can be reused for the berms or transported off-site. Topsoil can be sold if it is in good condition. The photo above shows the topsoil being removed by an excavator and stored in a long pile called a windrow. The windrow runs alongside the cleared area so that it can be quickly reinstated to the berm areas when the road is completed. You can also see the excavator just removing the dark brown topsoil to expose the light brown clay beneath it. This clay is a suitable surface for a road. Note that the excavator on the left is compressing the windrowed material, so the surface is less permeable, which means the topsoil underneath will not get saturated if it rains. Instead of windrowing the topsoil on site, it can be loaded onto trucks and then transported to either a stockpile on site or transported off site for disposal or sale. The next step is earthworks. Earthworks is reshaping the existing ground surface to make it suitable for a road. One reason for doing this is to provide a smooth road with constant rises and falls and slopes that trucks and other vehicles can climb. Another reason may be to lift the road above flood levels. The earthworks may consist of just smoothing out the soil, as would be the case in flat land, or it can involve moving significant amounts of soil, as would be the case in hilly terrain. This photo shows excavators excavating a cut for a road. The excavator in the background is loading up a Moxie, which is a specialist earth-moving truck. You may also see the top of a bulldozer behind the front excavator. Bulldozers are able to push lots of material short distances, but you need trucks to haul soil over longer distances. The other main piece of plant used in cutting and moving soil are scrapers, which are able to load and transport soils over long distances and then lay them in a thin layer ready for compaction. In fill areas, the soil is spread out in layers of 200 to 300 millimeters thick, usually using a bulldozer. The soil is then compacted to increase its density and hence its strength. This is done using compactors, also known as rollers. This photo shows a clay being compacted using a sheep's foot roller. A sheep's foot roller has knobs on the roller which makes it more efficient at compacting clays and silts. Vibrating, smooth-surfaced rollers are used for gravels and sands. Note also this roller has a blade on the front which allows it to doze the soil into a layer 200 to 300 millimeters thick. We need to have the layer this thin to ensure that the whole layer is compacted. Soil at the bottom of a thicker layer would not get compacted. The subsoil drains on either side of the road are installed to provide subsoil drainage. This usually involves excavating a trench using an excavator with a trenching bucket, laying the pipe by hand, and then tipping the drainage aggregate from an excavator or a loader into the trench. This photo shows a subsoil drain being installed. The top part of the photo has been installed and you can see the top of the drainage aggregate. They are using scoria for this drain. Scoria is a red volcanic rock that was common in Auckland. However, it's not used much as there is not much available scoria in Auckland anymore. The trench has yet to be dug up for the bottom section of the subsoil drain. You can see the pipe waiting to be installed. This pipe is wrapped in filter fabric. Filter fabric allows water to drain into the pipe but stops clay particles which would block up the pipe. Note there is the top of a stormwater system manhole in the bottom of the photo, and I assume they're connecting the drain directly into the stormwater system. The drainage pipes and any other services such as wastewater, water, telecom and power are usually installed when a section of the road has been built up to the final levels and shape. In particular, the pipes, culverts and ducts that run under the road need to be laid before the subgrade is completed and the pavement is laid. If this is not done, then you will end up digging up the road you just laid or using more expensive pipe laying methods such as directional drilling. Laying pipes and ducts basically involves digging a trench using an excavator, laying the bedding material and the pipe, and then backfilling using an excavator. The subgrade needs to be compacted to give it the required compaction and strength and trimmed to the required shape. The compaction is usually done with a smooth steel roller or a pneumatic tired roller, otherwise known as a PTR. These rollers tighten up the surface, making it more impermeable and stronger. The surface is usually shaped to the same shape as the final road so that the water on the subgrade surface flows to the subsoil drains to the side of the road. This photo shows a grader shaping the subgrade surface. Note the subsoil drains on either side of the road. Sometimes the subgrade soil is not strong enough and it needs to be treated to provide the required strength. This is most commonly done by lime or cement stabilization. For example, Auckland clays are often soft and usually require lime stabilization. The stabilization process involves mixing hydrated lime or cement into the top 200 to 300 millimeters of the soil. The mixture then hardens over the next few days to provide a strong surface layer. This photo shows a lime stabilization process in action. The lime has already been laid and hydrated. It is the white material on the road. The white machine is the rotary hoe, which is mixing the lime into the underlying soil. You can see that the material behind the rotary hoe is a mix of lime and soil. The compactor behind the rotary hoe is compacting the lime soil mix. A grader then came along and shaped the surface. The compaction and shaping need to happen at the same time as the lime is laid, as the hardened material is very hard to shape after a few days. Subbase is laid on top of the subgrade. This is usually laid in layers from moving trucks as shown in this photo. This method minimizes the amount of working required to get the subbase into a layer that can be compacted. If you move subbase or any aggregate around too much, you end up separating the coarse particles from the fine particles, and the aggregate no longer has the grading required to form a compact interlocking layer that can meet the required strength. The layers are compacted with vibrating steel rollers. These rollers vibrate and compact the subbase aggregate into a dense, strong layer of interlocking aggregate particles. The layers should not be any thicker than 200 to 300 millimeters thick to allow the whole depth of the subbase to be compacted. The top of the layer is tested to check that it has the required strength before the next layer can be laid. This photo shows the surface of the subbase being compacted using a vibrating roller. The roller is compacting the left side of the road. The aggregate to the right of the compacted area is as it was when it was laid from a delivery truck. Note that the compacted surface has compacted down a bit and the aggregate particles are starting to lock together as compared to the loose particles in the uncompacted area. The top of the subbase is shaped to the required levels using a grader. Graders are specialist pieces of plant that are designed to enable them to shape an aggregate layer to the required shape and level. The operator sets the blade to the correct level and camber and then drives along the road. High areas of aggregate are skimmed off and pushed into low areas, while excess material moves along the blade to form a windrow at the side of it. If it is included in the design, as is the case for most urban roads, the curb and channel is laid next and is constructed on the subbase. Curb and channel may be individual blocks placed in a concrete bed or a continuously cast section laid by a specialist curb and channel laying machine. This photo shows a crew laying curb and channel using a machine. The concrete is being poured into the top of the machine, which compacts a section into a shape and then steps on to the next section. The concrete is a special blend that has less water than usual and so is quite stiff. This allows it to maintain its shape when it is laid and before it dries. Note the string line that provides the operator with a guide to the alignment of the curb and channel. They would have also used the string line when preparing the base to ensure the curb and channel is at the correct level. The worker in the foreground is manually shaping the section that connects to the existing curb. The curb and channel confines the base course layer when it's laid. The base course needs to be compacted adjacent to the curb and channel, which can induce horizontal forces on it. This means that the curb and channel section needs to be left for a week or so to properly set and develop most of its strength. Concrete typically develops about 50% of its strength 1 week after laying and 90% after 28 days. If the concrete is not allowed to develop sufficient strength, then the curb and channel would crack due to the lateral forces caused when the base course is compacted. The base course is laid on a subbase layer. The base course laying and compaction process is much like the subbase layer construction in that it is usually laid in layers from moving trucks, compacted with vibrating or steel rollers, and shaped using a grader. The top layer of the base course needs to be very tightly bound to resist the horizontal forces from turning, braking, and accelerating vehicles. This is done using a pneumatic tired roller, or PTR, which is a compactor with rubber tires. The movement of the tires tends to knead the surface that forces the surface particles into a tighter matrix. Steel rollers may also be used for this job. When properly compacted, a granular layer should have a stone mosaic finish. That is, you should be able to see the coarse aggregate particles embedded in the fines as shown in the photo. The gravel particles should be so tightly bound into the layer that it is very hard to prise them out, even with tools. This photo shows the subbase surface close to being complete. You can see the coarse particles tightly bound in by the finer particles. A surfacing layer providing waterproofing and good wearing service is usually laid on the road. This may be a chip seal or asphaltic concrete, or a combination. Let's look at chip sealing first. In chip sealing, the bitumen is laid from a bitumen spray truck as shown in the photo. This truck transports the bitumen to the site and then sprays it from a sprayer arrayed along the back of the truck. In this photo, they have it hidden behind a fabric protection curtain. Once the bitumen has been laid, chip needs to be laid on top immediately after, before the bitumen has set. This photo shows the chip being laid. You can see the bitumen has already been laid in a thin layer over the base course surface. The truck is now laying the chip. You can see that the truck tray is tipped, so the chip slides to the edge of the tray where there is a chip spreader. The chip spreader is a rotating roller that spreads the chip evenly across the road at a controlled rate. The worker is controlling the rate at which the chip is laid on the surface to make sure they're getting the right coverage. Note the truck is traveling backwards, so it's moving on the chip that it has just laid. Bitumen is very sticky and will stick to tires if the chip layer was not there, so the driver needs to make sure he stops before he runs out of chip. The chip is then compacted using a pneumatic tired roller, or PTR. This type of roller pushes the chip into the bitumen but also provides a kneading action that causes the chip to roll over, so it locks in into a tight interconnected layer. An alternative to chip sealing is asphaltic concrete. Asphaltic concrete is a mix of bitumen and smaller sized chip. Each piece of chip is encased in a layer of bitumen, which all stick together when the material is compacted. Sometimes a layer of thin bitumen is laid on top of the base course before surfacing. This is called a tack coat, and it helps the surfacing adhere to the base course layer. This photo shows asphaltic concrete being laid using a paving machine. The truck carried the asphaltic concrete to site from a batching plant where the aggregate and bitumen would have been mixed. The truck tips the asphaltic concrete into the hopper of the paving machine, which then lays it in an even layer across the width of the machine. Steel-tired rollers would follow to compact the surface further, although asphaltic concrete is pretty well compacted by the paving machine. This video has provided a quick overview of road construction processes. We will look at road construction processes in more detail in later videos.